In this video, we will discuss adjusting the displacement or deformation scale that get displayed in our simulation result. So here we have the results of a beam simulation study that we have conducted. In top of the canvas, we have a small information box which has the deformation scale, which in this case, it is a factor of almost 2,800, meaning that the deformation image we have in the interface is very exaggerated by a factor of 2,800. If we go to the displacement plot, which we have here by default, so I'll go ahead and double click on that, we can find out the actual resulted deformation from our study. And we can read that here in the legend, which is at about 0.07 millimeters, which is barely notable to the naked eye. Depending on the situation, this inflated displacement presentation might be a bit too much for our purpose, and so we can adjust it manually to a more suitable scaling. To change the scale, we can right-click on the plot we're at. So here we have the displacement plot. I'll right-click on that and then select Edit Definition. And here we will find an option to change the scale. By default, the scale will be set up to an automatic value, and we can change that to the actual true value or to a custom scale. So let's go ahead and experiment with those. I'm going to change the automatic scale to true scale and then click on the green check mark. And this will simulate the actual deformation the beam gets exposed to. However, that deformation is about 0.07 millimeters, which is barely notable compared to the length of this beam. And this is why we can see the beam looking almost like a straight line still. And so for our purpose, this scale might not be proper because it doesn't show how the beam will react to the loads it gets exposed to. So let's go ahead and change that. I'll go back to my edit definition, and then this time select user defined. And I'm going to change that to 1,500 and then click on the green check mark. This representation shows how the beam will react to the load, but also at the same time, in my perspective, it's not too exaggerated or it's not too much for a representation. And so if I'm satisfied with that, I can go ahead and leave it as such. Keep in mind that when we change the scale in one plot, it will not be changed in the other plots as well. So here we just change the scale in the displacement. If I go back to my stress plot, you will notice that the deformation is much more, reflecting the older automatic scale. Whenever we're setting up our own custom scale, there is no right or wrong answers for the scale we should use. As long as it can support the communication we are trying to do, then it should be good. In many instances, this might involve a few cycles of trial and error until we get the type of image that will work best for us. And by this, we conclude this video on scaling.